It takes 3 stages to complete the production of a spare part. In the first stage, each worker can produce 50 spare parts. In the second stage, each worker can produce 30 spare parts per hour. In the third stage, each worker can produce 25 spare parts per hour. Okay, so it's almost like assembly line there. Okay, so we need to make sure we have a continuous and balanced production, meaning no stage has to wait for the other. So how many workers should be assigned to each stage at minimum? Okay, now let's see what the question means. Okay, so for the first stage, each person can make 50 parts per hour. If we have 2 workers for stage 1, okay, we should be able to make 100 parts per hour. If we have 3 workers, they should be able to make 150 parts per hour, right? So the number just can go on. We're not going to list all of them. Now let's look at stage 2. Okay, so one person, 1 hour can make 30 spare parts. What about 2 workers? 2 workers per hour can make 60 spare parts. What about 3 workers? 3 workers can make 90 spare parts per hour. Again, the number also goes on. Now let's look at stage 3. Okay, so in 1 hour, each worker makes 25 parts. Okay, 2 workers per hour can make 50 parts. Okay, 3 workers can make 75 parts, right? The number can go on. So to make sure that the production is continuous and balanced, so no one is waiting for the other, we want to first of all make sure that every stage is assembling the same number of spare parts. Let's first of all make sure of that. The same number of spare parts. For example, if stage 1 is producing, say, 200 spare parts, then stage 2 and stage 3 are also doing that. They are making the same number of spare parts. Then how do we find the same number of spare parts first? Okay, we know that 150, 90, 75, those are all multiples of 50, 30, and 25. So first of all, let's find the common multiple for all 50, 30, and 25. The common multiple means the same number of spare parts that each station needs to make. Okay, let's start with finding the least common multiple. Why the least? Because we said that at minimum, okay, how many workers are needed? So 50, 30, and 25. Let's find the least common multiple for the 3 numbers so that we know we can start from the same number of parts that each station has to make. So we're going to divide that into 5 into that. That's 10. That is 6. That is 5. Okay, we can still factor. So between 6 and 5, between 10 and 5, I have 5 there. That's 2. And 6, of course, is not factors. It's not factored, and 5. Okay, there we go. So now let's multiply 5 with 5. That's 25 times 2. That's, sorry about that. We can still go on between 2 and 6. Okay, 2 into 2, that's 1. That's 3, that's 1. Okay, 2 times 2, that's 25. Times 2, that's 50. Okay, 3 times 50, that's 150. So the least common multiple of 50, 30, and 25 is 150. This is how we got it. Okay, so that means we're going to start from 150. That's the same number of spare parts for every station. All right, so I'm going to stop right here now. I'm going to delete everything. So we know that 150 spare parts is the least number of spare parts that we can start with, so that every stage will have the same number of spare parts. All right, let's go. So now for stage one to produce 150 spare parts, we would need three workers. Because one worker can make 50 spare parts, right? Then we will need three workers for stage one to be able to make 150 spare parts. Then for stage two, we would need five workers to make 150 spare parts in 1 hour. Then for stage three, we would need six workers to make 150 spare parts. Please remember 3, 5, 6. Those are the minimum number of workers that we need to make sure that the production is continuous and balanced so that no one is waiting for the other. Again, can we do 3 times 2, 5 times 2, 6 times 2? Yes. We can also arrange the 6 workers in one station, stage 1, or 10 workers for stage 2, and 12 workers for stage 3. If we do that, we can still have a continuous and balanced production. But again, the question says, how many workers do we need at each stage at minimum? So at minimum, stage 1 needs 3 workers, stage 2 needs 5 workers, stage 3 needs 6 workers to keep the production continuous and balanced so that no stage has to wait for the other.